Good day, everyone. This is Mom G. Hansel P. Mundigo, and welcome to my lecture video. In this video, I am going to discuss to you the proving of the special right triangle theorem, or what we call the 30-degree, 60-degree, and 90-degree. In this theorem, we shall encounter an equal length of the side. This is why we will name the non-hypotenuse side as either the shorter legs or the longer legs, rather than just saying the legs. So this theorem states that in a 30-degree, 60-degree, and 90-degree triangle, the length of the hypotenuse is twice the length of the shorter leg, and the length of the longer leg is equal to the square root of 3 of the shorter leg. Here we have the given PQR is right angled at Q. So since it is a right angled at Q, we have now the angle P 30 degree and angle R which is 60 degree. In this slide, we are going to prove if this equilateral triangle is true. Since we know that if we are going to cut out this equilateral, we can form a triangle or right triangle that measures 30 degree, 60 degree, and 90 degree. So if we construct a mirror of this triangle, or if we are going to draw the opposite in the left side, then we could also create a equilateral triangle. So now let's prove if this equilateral is true. We have here the first statement or the given. The triangle PQR is right angled at angled PQR. So this means that this angle, the measurement of our angle PQR is 90 degree. And then the measurement of our RPQ is 30 degree. And the last one, the measurement of our angle QRP is 60 degrees. So number 2, by constructing the triangle PQS, where the measurement of our SPQ here, our angle P is 30 degree. Also, we have SQ plus QR is equals to SR, and our SQ is equal to QR. So this is by construction. So if we construct the mirror of our right triangle. Next, since we have the angle PSQ where it is a mirror of our original triangle, then we have also a angle S which is 60 degrees. And the measurement of our angle S PR is equal to our measurement of angle S PQ plus angle RPQ. So this means that if we are going to add or get the sum of our angle here, then we could get the angle 60, which is equal to our angle R and angle S. So this is also true that the measurement of angle SPR is 60 degree. Now we have the measurement of our angle PSR is equal to our measurement of our angle PSQ. Yes, because this is an equilateral triangle, and we know that all sides and all angles are equal, and congruent. Here, we have, by transitive property, we have here the measurement of our angle PSR. PSR is 60 degree, and our angle SRP is also 60 degree. Now, in number 8, by transitive property again, we have the measurement of our angle as PR is equals to measurement of our angle PSR is equals to measurement of our angle PRS. So this only means that all the angle S, angle P, and angle R are congruent. So they have 60 degrees. In number 9, so since we all know that all the angles are congruent, we could say that this is an equiangular triangle, or the triangle PQS is an equiangular triangle. The last one is a triangle PQS is an equiangular triangle also. So they were all the same, the original and the triangle that we have drawn or we have constructed. So by here, we prove that this is an equilateral triangle. In the next slide, let us look at the relationship of the sides. So again, we have here the equilateral triangle, or we have the original and the constructed triangle. So given this triangle PQR angled at Q. So the first statement is RS is equals to SR. So this is in the definition of our equilateral triangle. So our PR is just equal to our SR. Now, our PR is equals to SQ plus QR. So when we are going to get the sum of the SQ and QR, this is just equal to our PR. Next, the PR is equals to QR plus QR. So this is according to a substitution property. Since we know that our SQ is just equal to our QR, then we could also say that QR plus QR is just also equal to our PR. Now, in number 15, by Pythagorean theorem, since this is a right triangle, we could create this formula or this Pythagorean theorem formula. So just simply substitute the PR. We have PR squared is equals to QR. Here, to QR squared plus PQ squared. So, in number 16, using this substitution property, since we know that our PR here is just equal to our 2QR, then we could simply substitute, or we could say, or this is still true, that our 2QR squared is equals to our QR squared plus PQ squared. So here in number 17, by the laws of exponent, we could multiply the squared to our number. So 2 times 2, we have 4, and QR times QR, we have still QR squared. So equals to QR squared plus PQ squared. So by subtraction property, or subtraction property of inequality, we could, to get our PQ here, we could subtract both sides. So if we are going to subtract QR here in the right side, then we could also subtract QR on the right side. So we have now left 3QR squared plus is equal to PQ squared. Number 19, so by the square root property, so to get our PQ here, we put it in the square root. So we have cancel our squared and our square root. Also here, our QR squared, cancel ang squared and r squared. So, the remaining will be QR square root of 3 is equals to PQ. So, this means that our PQ is just equal to our QR square root of 3. So, by that, we have proved that our PR is equal to 2QR and our PQ is equals to QR square root of 3. It might be very long proof. Nevertheless, since we have established this, we can say this relationship. So from the original and constructed triangle where we can create an equilateral triangle, we can have this triangle, the PQR, where the hypotenuse or the PR is 2x and our PQ is x square root of 3 and our QR is Rx. So to know this, we can have our example here. So given the PQR is right angled at Q, so we have here the figure. The right triangle PQR angled at Q. So if QR is 8, find PR equals to x and QP or PQ is equals to y. First is we're going to solve for x. Since we know that our x or our hypotenuse is equals to 2QR, then we could substitute the QR. So we have here, since our QR here is given, so we could simply substitute. Now we have x is equal to 2 times 8. So 2 times 8 is equals to 16. So, therefore, our x here is 16. So now let's find the value of our y. So, since we know, according to our theorem, that y is equal, or our PQ is just equal to our QR square root of 3, then we could simply substitute since we have now the QR. So, we have here y is equal to 8 square root of 3. In here, we have found the value of our y, which is 8 square root of 3, and x, which is 16. So it is easy to get the value of our x and y if we know the theorem, the 30 degree, 60 degree, and 90 degree. So that's all. This is Ma'am Gia Hansang Mundigo. Thank you for watching.